Lesson 5.1, still doing the second part of the lesson that we haven't gotten to yet. And that is solving trig equations. Now, as we solve these, we are trying to find the values of, are they all in terms of x? Yes. The values in terms of x that make these equations true. Okay? So I say values because there might be one value that makes this equation true. There might be more than one value that makes the equation true, depending on the trig statement that you're solving. Some of these, like number 1, there's no solving to do. We just need to think about when does sine x equal 1/2 and come up with any answer or answers. Some of these, as you look at some of the rest, we'll have to do some manipulation first. Maybe do some factoring, maybe do some foiling, maybe identify a Pythagorean identity or a quotient identity, or, just some of the same type manipulations we did previously. Okay? So, you will also notice in the directions, and I have it over here with the homework, it says on the interval 0 to 2 pi. So, meaning 0 to 2 pi represents what? One revolution around the unit circle, yes? So that means I want any and all answers that make that statement true once around the unit circle. Officially, if I don't limit it to on the interval 0 to 2 pi, there's an infinite. Officially, it should just be a bracket on the 0 and a parenthesis on the 2 pi because I don't officially want that answer up to 2 pi. I want everything up until 2 pi, but not that answer right there. Does that make sense? So, it'll make you feel better if I, there. Now it's a parenthesis. Valid point, probably should be changed there. I thought to change on the board, but not there. Okay, so, sine x equals 1/2. You've had these unit circles in front of you for a few minutes. When does sine equal 1/2? Pi over 6, and I don't know are you looking at your unit circle or your chart for that? The chart's the easiest thing to go to, yes? And as I go to the chart, I'm looking where does sine equal 1/2? And that is pi over 6. Now, is that the only answer? Not necessarily, because pi over 6 happens in quadrant 1. And does sine x equal positive 1/2? Is that positive 1/2 in quadrant 1? Yeah, because everything's positive in quadrant 1. So, okay, we've got that positive answer. But where else is sine positive? Okay. So, all students take calculus, right? We already found this answer. We know that there is an answer in quadrant 1. And we know that sine equals 1/2 at pi over 6. Anytime you have it equaling a positive in its typical quadrants, you're going to have 2 answers. If it said equals negative, you would also have 2 answers. So, sounds like you guys are figuring out my other answer is in quadrant 2. So, pi over 6 is on the right in quadrant 2. Let's grab a blank one because I don't know where my unit circle is right now. Blank one works just as well for me. Okay. So, 5 pi over 6, right? Because you're going pi over 6 up from the x-axis. So, pi over 6 up is 5 pi over 6. Do I have any other answers? No, because down in quadrants 3 and 4, sine is negative. So you have 2 answers. The comment I'm going to put right here as a reminder is check unit circle for values. Okay? In other words, it will happen, but it's not necessarily a regular occurrence that there's only one answer on a problem. There could be one answer, there could be 2 answers, there could be 3 answers, 4 answers. I don't know, even more depending on the problem. Okay, so 2. We're going to kind of do a progression here, progressively add in different details and steps. 1, we already had this equation solved. We just had to answer it. It was sine x equal 1/2. 2, we have cosine x plus 1 equals 0. Okay, so just like a normal typical equation solving, your job is to get the variable by itself, yes? Well, getting the variable by itself means getting the trig unit by itself, which means getting cosine x by itself. So, I agree, subtract 1. So then, this becomes cosine x equals -1. Variable by itself, so to speak. In other words, a trig function's by itself, right? When does cosine x equal -1? Is the question you're answering yourself. So my answer is officially going to be x equals something. I want to know when I plug in what angle or angles cosine of blank is going to give me -1. What? Pi. Why pi? What? Cosine equals -1? 1 or -1? You need to look at your quadrant angles, yes? And so when does cosine equal -1? Where is cosine in an ordered pair? Cosine is the first thing, right? The x value. So as I look at my ordered pairs, where is x -1? And that's happening over at pi. Other answers? Huh? When you're looking for things like when does -1, it's just checking your quadrant angles. Okay, 3 pi. I agree 3 pi, however, I only need answers between 0 and 2 pi. So once you've given pi, you've given that. Are there any other answers? No. But what was my point of that? As annoyed with me as you are right now, trying to get you to think, right? Like you have to stop and think. Don't just, okay, I'm going to write down one answer, I'm done. You might be. You also might not be. And so in this case, x equals pi. And it's, my visual is that right over here, my ordered pair is -1, 0. And that happens at pi. So you can't see my visual that I just wrote, sorry. But that's my visual that you have to, you know, think about your ordered pairs there. Officially, you guys know your sine and cosine graphs now, yes? And don't you dare tell me you've already forgotten. Think about cosine. What's cosine do? Cosine looks like this, yes? Max of 1, min of -1, that's at 0, cuts through at pi over 2, has a minimum at pi, cuts through at 3 pi over 2, and has a max above 2 pi, yes? What do you notice right here? Cosine of pi equals -1. So, first, and then draw my graph. Not good here, but you'll deal, okay? Pi, -1. Some of you guys are still going to use the unit circle way we just went through, yes? Some of you that are more confident with your sine and cosine graphs, I'll be honest, this is what I go to. Where does cosine equal -1? And that happens at pi. Connection? Huh? Okay. We're going with 1 and 2 then. Got some basics happening. Okay. Let's move on and look at number. I'm not going to. Huh? I have to think differently this time. Okay, so the suggestion up here was add the 2. I'm going to veto that suggestion this time. My reasoning for vetoing it is if it was just a cosine squared term or just a cosine term, I'd be all for it. I have to veto it because there's a cosine squared and a cosine. Did I hear the word? Factor? No, actually, you may think you're being sarcastic, but actually, we are going to factor here. Okay? Now, here's your thought process. Here's what I'm going to suggest you think. I'm going to write it right above here. Instead of cosine squared x, think of that as x squared. Instead of cosine x, think of it as x. If this equation was x squared plus x minus 2 equals 0, what would you do? Just because they're cosines does not change the process. Cosine x is our variable instead of x. So, this is what we're thinking. Let's go ahead and factor it in terms of just plain x's so everyone can see that. X squared breaks into x and x. I need numbers that multiply to be negative 2 and add to be 1. And those numbers are 2 and negative 1. So my parentheses, if it was just x, you are going to use that every time we do one of these problems. Some of you are going to use it right now, and then you'll figure it out and not need it. Okay. Basically, this is a quadratic trig function is what it is. So if you have a quadratic trig function, we want to set it equal to 0 and factor. 2 parentheses. If x squared gets split into x times x, what's cosine x squared? Cosine squared x gets split into cosine x times cosine x. And those numbers are still plus 2 and minus 1. Okay, typical algebra solving steps with trig functions involved. Once you have the 2 parentheses, what would we have done up here? We would have set them both equal to 0. I have 2 parentheses down here, so we're going to set them both equal to 0. Cosine x plus 2 equals 0, or cosine x, subtract 2, add 1. Cosine x equals negative 2, or cosine x equals positive 1. Am I done? No. We need the angles now, okay? We need the angles. When does cosine equal negative 2? When does cosine equal 1? Two pi, but what's the smaller name for 2 pi? 0. Okay, so I'll be looking for the number 0 here. So in this one, x equals 0, as in 0 degrees or 0 radians. You'll notice we're pretty much working in radians here. Okay, we could also say 2 pi, 4 pi, 6 pi, but when does cosine equal negative 2? When does my cosine graph that I drew on the board, last problem, equal negative 2? Never. Does a plain old typical cosine graph ever go as low as negative 2? No, not with either a translation down or a stretch that's going to pull it down. But this is just typical cosine, yes? So on this one, there is no answer for that one, okay? Because that one is not possible. Make sense? And which, by the way, when does cosine equal 1? I forgot to go back to this graph. When does cosine equal 1? Right here at 0, yes? Okay, number 4. Here we go. Two sine squared x plus sine x minus 1 equals 0. Yes? So, is it factoring like last time? Okay. We're going to be factoring like last time in that it's going to be 2 parentheses again. Now, I'm not 100% sure about your 2 out front comments. C problem is what it's going to be. Okay? Or, if you're capable of a good old guess and check, which this one's pretty doable in guess and check, if you can get your brain to work that way. Some of you do, some of you don't, which is fine. Product of AC still works for all of these, right? Okay, so, side note, if you need it, what is this problem equivalent to in straightforward algebra? 2 sine squared x plus sine x minus 1, what is it we're really going to be factoring? 2x squared plus x minus 1 equals 0. That's what you're truly factoring if you need to see it without the signs. So ideally, we're getting it to 2 parentheses. Will you try guess and check with me? This one is incredibly easy for guess and check because there's not options. The only thing we have to figure out are signs. What is the only way in a typical factoring problem like this to break up 2x squared? What's going to have to break up into? 2x and 1x? 2x and x, right? So, in a factoring problem like this, since 2 is prime, I know it's going to have to be 2x and x. It'd be different if this was like 4x squared. Excuse me. Is it 4 and 1 or is it 2 and 2? But on a prime number like this, it's easy. On the numbers at the back here, they have to be the numbers that multiply to be 1. What are my only options for numbers multiplying to be 1 in a situation like this? 1 and 1. Now, we have to get our signs to work out. We need our numbers to multiply to be -1, but then add to have a positive 1 in the middle. So outsides, it's a positive 2x. As I FOIL my insides, it's a positive, or it's a 1x. I don't know why I said positive. It's a 2x and a 1x. How do I make it so that I have a positive 1x in the middle as a result? Is the 2x or the 1x positive, and which one's negative? Yeah, 2x has to be positive. So that's 2x times this last one. So that's an x plus 1. This 1 times x right here needs to be negative. Now, did everyone like that or no? Do you remember product of AC? You can do product of AC because that's plan B. And if it had been a more difficult problem, I definitely would have taken you product of AC because I know that's where you guys are comfortable at. Okay, so how does this translate down into what I really need for this trig equation? Instead of 2x minus 1, what am I writing? 2 sine x minus 1. Instead of x plus 1, what am I writing? Plus 1 equals 0. Are you catching on? Okay. Take it away. What do we do now? Set each part equal to 0. So 2 sine x minus 1 equals 0, or sine x plus 1 equals 0. Now what? Solve them, yes. 2 sine x minus 1. What happens? Yeah, ends up being 1/2 because you add 1. So 2 sine x equals 1. Divide by 2. And we're going to need to know, when does sine x equal 1/2? Hold that thought. We'll come back to that in a moment. Sine x plus 1 equals 0. Subtract the 1 over. And so we're going to need to know, when does sine x equal negative 1? Okay. When does sine x equal 1/2? Pi over 6, according to our chart, or according to the y coordinate on pi over 6 on my circle. Does it equal 1/2 anyplace else? Yeah. If you give a quadrant answer, like from within a quadrant, not just the quadrant angles, you're probably going to have 2. There's 2 places that sine equals positive 1/2. What's the other one? 5 pi over 6. Do these numbers sound familiar? Hello, cheat off of yourself. What would we answer number 1? Oh, pi over 6 and 5 pi over 6. So right here, x equals pi over 6, 5 pi over 6. Am I done? No. With that half of the problem, when does sine x equal negative 1? So when, which of my quadrant angles does sine equal negative 1? So when is my y value negative 1? When you go down on the 270 thing, right? So 3 pi over 2. Is there another answer for that one? When else does sine equal negative 1? There isn't. Okay, so how many answers did I end up with? 3. As I said, every problem is a little different. And this is where this has its own challenges, as does the ones where we're trying to simplify them. Solving has its own set of challenges. Okay. Ready for number 5? Tangent squared x minus secant squared x minus 5 equals 0. Thoughts? What? We have a slight problem with product of AC here. Well, it's not even the fact that they're both squared. They're not the same function. So, in a way, this is like having a 3x squared minus y squared minus 5. Okay? In a way, so it's kind of like having 2 different variables when we're thinking in terms of that. Identities, huh? Specifically Pythagorean identities? Okay, so even though it doesn't look like it right now, like you suggested, product of AC. The only reason I vetoed product of AC, well, I guess you point out that there's 2 squareds, but even bigger than that is there 2 different functions. With the help of our Pythagorean addition, and then go from there. Now, which Pythagorean identity do I need to use? That middle one. The one that says 1 plus tangent squared equals secant squared. Do I have that correct? Okay. Well, you can do it one of two ways. You actually have an option here. Not everyone has to go the same direction. We can turn this equation so that it is either all in terms of tangent squareds or all in terms of secant squareds. It honestly doesn't matter here. Okay? Honestly, because it says 1 plus tangent squared equals secant squared, what I would do is take that secant squared right there and replace it with the other part of the Pythagorean identity. Could you manipulate the other one though and do it just the same? You can. Okay? So I'm writing PI there as when you look back at this and say, what did we do? We used the Pythagorean identity. So I'm going to write 3 tangent squared x 1 plus tangent squared x. I'm ending my parentheses. I still have a minus 5 equals 0. So do you see what I did there? I took my secant squared and replaced it with a 1 plus tangent squared. I used an identity, and this was just all in the name of, now my problem is only in terms of tangent. So if you would, let's distribute that negative. In other words, I'm rewriting it without the parentheses. 3 tangent squared x what? Yeah, like terms. Can 3 tangent squared be combined with a minus tangent squared? Yeah. What is 3 tangent squared minus tangent squared? 2 tangent squared. So 2 tangent squared x, and then minus 1 minus 5 is minus 6 equals 0. Now what? What? You could. I had a slightly different plan in mind, but that would work. If you're stuck right now, ask yourself, what would you do if this equation read 2x squared minus 6? If this was just a straight up algebra problem, what would you do? Add 6 and then divide by 2. Now, factoring the 2 out, does that work also? It does. I think a lot of you guys probably like it better if we add the 6 and divide the 2 though. So, add the 6. I have 2 tangent squared x equals 6. Divide by 2. Tangent squared x equals 3. Again, yeah, if this said x squared equals 3, what would you do? Square root. Since it says tangent squared equals 3, square root. What's the square root of tangent squared? Tangent x. What's the square root of 3? Plus or minus the square root of 3? Is that important? Oh yeah. You don't put that negative on there, you just lost half your answers. Because as I think about this, what are we looking for? We're looking for any place that tangent x equals positive square root of 3, and any place tangent x equals negative square root of 3. Oops, I took that. Don't get into number 6 too much like I'm starting to do. So, let's start in quadrant 1. Let's get, when does tangent equal square root of 3? Pi over 3? Okay, according to your chart, tangent and this is your box chart, right? Your reference chart. Tangent is square root of 3 at pi over 3. I can look at my, and that would be square root of 3 over 2 divided by 1 over 2. So square root of 3 divided by 1. So right there is pi over 3. What other quadrant do I need to look at for the positive answer? For the positive answer, all students take calculus. Okay? So that means I need an answer down here from quadrant 3. What is the equivalent answer in quadrant 3? 4 pi over 3. It is pi over 3 below the x-axis. So there's two positive answers. Pi over 3, 4 pi over 3. Am I done? No, we also need... So what's in the short of it, what's happening here? Heard someone earlier say 4 answers, right? You need 1 from each of the 2 positive quadrants, and you need 1 from each of the 2 negative quadrants. What's my answer in quadrant 2? 2 pi over 3, because that is the pi over 3 equivalence up there. And then what's my answer in quadrant 4? Quadrant 4 is 3. Now, officially, you can write those answers in any form you want. The answers I just gave is I gave my 2 positive quadrants and my 2 negative. Quadrant 3, 4 pi over 3. And quadrant 4, 5 pi over 3. Here's mine. I just want all 4 answers from you. That's the key. Okay. Are you starting to get a feel for this a little bit? This is where we have to leave off for today. Here's what I'm going to say. I am going to come back and finish notes tomorrow. Okay, number 6 is a good one to look at. 7 and 8 we need to look at. But on the flip side of that, you also know a lot to start into homework tonight. So it wouldn't be a bad idea, homework will not be due till Friday, but to go ahead and start into the homework. And that way you can kind of start to see where your questions are and come back better prepared tomorrow to finish these and go over any questions. Okay? And that was page 411, 51 to 62.